You think you understand force. You push a door, it opens. You kick a ball, it moves. You drop something, it falls. Simple, obvious, almost too obvious to question. But pause for a moment. What exactly are you experiencing? When you say you applied a force, what does that actually mean? You don't see force. You don't touch force. You only see what happens after movement, acceleration, change, effects, always effects, never the thing itself. So where is it? You feel your weight right now, the ground pressing against your feet. You call that force, but is that really force or just pressure? Something pushing back? You think force is this invisible push or pull acting between objects. That's what you've always been told. But think deeper. If force is real, why can't you ever isolate it? Why can't you point to it directly? You can measure motion. You can measure mass. You can measure distance. But force, you calculate it, you infer it, you assume it must be there because something changed. It seems obvious until you notice something strange. Everything you call force is just a description of change. Not a thing, but a label, a shortcut, a way of talking about motion. So here's the unsettling question. If force is only something you calculate, not something you directly observe, then what is really causing things to move? And more importantly, what have we been misunderstanding all along? Because the moment you start asking that, the simple idea of force begins to fall apart. And once it does, you can't look at motion the same way again. Something deeper is hiding beneath every push, every fall, every movement you thought you understood. And the deeper you look, the less certain everything becomes. Right before everything changes, so you try to make it precise. You define force the way physics does, not as something you feel, but as something that causes change in motion. Objects don't move unless a force acts. That's the rule. It sounds solid, clean, mathematical. You give it a form, a structure, an equation that seems to explain everything. F equals ma. This tells you that force is equal to mass times acceleration. It feels like you finally captured it, turned something vague into something exact. But look closer. This equation doesn't tell you what force is. It only tells you how to calculate it. It connects motion to numbers, not reality to meaning. You're still describing effects, not causes. Then things get stranger. Imagine two objects interacting without touching. A magnet pulling metal, the earth pulling you down. There's no visible connection, no rope, no contact. Yet something is happening. Early physicists called this action at a distance, and even they were uneasy about it. How can something affect another thing without touching it? It sounds almost like magic. So new ideas were introduced. Fields, invisible structures filling space, telling objects how to move. But that only pushes the mystery one step back. What is a field? You can't see it either. You only see what it does. Now you're in a loop. Force explains motion. Fields explain force. But both are defined by the same thing, their effects. Nothing is directly observed. Everything is inferred. And suddenly, the neat definition you trusted starts to crack. Because if every explanation relies on something you never actually observe, then maybe force isn't the fundamental thing you thought it was. Maybe it's just a shadow of something deeper, something the equations hint at but never fully reveal. And this is where everything quietly shifts. Because in modern physics, the idea of force starts to disappear. Not completely, but fundamentally. It's no longer treated as a thing in itself. Instead, it becomes something that emerges from deeper structures. What you once called a force is now described as an interaction, not a push or a pull, but a relationship between objects and the underlying fabric they exist in. Take gravity. It feels like a force pulling you down. But in Einstein's view, it isn't a force at all. Objects are simply following the natural curves of space-time. You're not being pulled. You're moving along a path that the universe has already shaped. the same shift happens elsewhere. Electric and magnetic effects are no longer just forces acting at a distance, but excitations in fields that exist everywhere. These fields aren't things you touch. They are the stage on which everything happens. Particles interact with these fields, and what you observe as force is just the result of that interaction. So the push you feel, the motion you see, the acceleration you measure, all of it comes from something deeper, something you never directly experience. And that leads to an uncomfortable realization. Force was never something you truly understood. It was a useful idea, a way to organize observations, a bridge between what you see and how you calculate it. But it was never the final answer. It was a layer, a simplification, a story we told to make sense of patterns. So when you ask, what is force, really? The most honest answer is this: it isn't what you think. It's not a thing you can point to. It's a reflection of deeper rules, deeper structures, deeper relationships that define how reality behaves. And the moment you see that, force stops being obvious. It becomes something far more unsettling. Because now you're not just questioning force, you're questioning whether anything you experience is as direct as it seems.